Hello. Whoops.
Good morning.
Hello. Hi.
Hello.
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 Hi, Helena. This is
Oh.
Kat. Can you hear me?
Now I can hear you. Thank you.
And it looks like 5 of us are logged in as participants and 4 attendees. This is Tom, by the way.
Hi, Tom. This is Helena.
This is Jim.
Good morning.
Tom, when I went back to the audio of the last virtual session,
Yeah.
I had a hard time telling. Some voices I know, but other voices I didn't. And so it may be good to have, when participants speak, to at least say their name a couple of times until.
Oh,
Yeah.
Good idea.
Yeah.
Yeah, I was probably too preoccupied to keep track, and I don't know anybody, so.
Hey, did anyone notice how many people attended the call on Monday? I never thought to look.
About 40.
Oh, okay. I was hoping there'd be more. I guess that's all right.
That sounds pretty good to me. Are these advertised to the wide world or kind of within the research community, or how far do the Monday webinar invites go?
They definitely go to the Gulf of Mexico Research Initiative listserv. So to the researchers that are funded through this agency.
Yeah.
I extend it to my research group, and then I also asked that Sea Grant extend it through their network.
Mm-hmm.
So it's more of a targeted audience as opposed to just a overall blanket invite.
Hopefully you can see my screen now.
Yes.
We're up to 15. I'm guessing a few more people will wander in, but I think we might as well launch. I think a couple of people are going to be on mute because they have various other commitments jointly with this and are just listening in. But why don't we do a quick round of introductions among the people who are speaking. So I'll launch. I'm Tom Fitteman. I'm with a small consulting company called Ventana Systems. And we are here to facilitate essentially designing synthesis of models or integration of models, recognizing that a lot of integration is evidently already underway. So we're essentially sniffing around to find the gaps and requirements and opportunities for making things more connected. So I actually came to integrated modeling through climate integrated assessment in the 90s. Spent a lot of time working on climate economy models. That was actually my dissertation. Since then, I've been kind of a dynamic modeling generalist, working a lot on energy economy, but also on other things, all the way from marketing science for fizzy drinks to aircraft manufacturing logistics to port commodity supply chains. But actually solving kind of big, messy, dynamic problems in all of those domains have a lot of things in common. So early on here, I'll talk a little bit about integrated modeling, although less than last time. Let's just kind of go around the virtual table, and I'd be interested to hear what other people are working on. Let's see, I think the list is dynamically reordering itself. So how about Cameron?
Hi, Cam Ainsworth. I'm a marine ecosystem modeler. I work with, well, a lot with Atlantis. It's an end-to-end biogeochemical food web model. And I'm an investigator on the Sea Image project, which is located at USF with Dr. Steve Manowski is the PI for that. And I'm an associate professor at the College of Marine Science. That's it.
Thanks. Helena.
Hi, I'm Helena Solo Gabriel. I'm a professor of civil and environmental engineering at the University of Miami. I'm the PI of the Beaches project funded through GoMRI, which stands for Beach Exposure and Child Health Study, where we're looking at children's activity on the beaches to understand their potential health risks. I'm here predominantly to listen. Thank you.
Jim.
Oh, hi. I'm Jim Ruzicka. I'm at Oregon State University, Cooperative Institute for Marine Resources Studies. And I work with a model platform called Ecotran, which is sort of a lower complexity version of Atlantis. And I've been involved with the development of the Ecotran modeling platform. And I also do applied that to different ecosystems, shelf ecosystems around the world. And I also work with NPZD plankton models. And currently, my involvement on this is I'm a co-I on a project looking at vertical trophic linkages that's led by Frank Hernandez.
Great. Elizabeth and Tracy, I'm guessing, are temporarily indisposed. There's somebody on who's a 910 number that doesn't have a name attached.
Hi,
hey, this is Tracy.
me.
Just wanted to let you know I was here. Oh, I'm sorry. I didn't mean to cut you off.
Hi. Okay.
No, sorry.
Sorry. Please go ahead.
So the 910 number is Missy Partika. I'm with Mississippi Alabama Sea Grant. I'm a member of the oil spill outreach team. My background is varied, but I've worked a lot in coastal ecosystems, and so I'm the member of our outreach team that's going to be listening in on this call.
Great. Back to Tracy.
Hey, apologies again for talking over you. I've got a little bit of a lag going on my phone. My name is Tracy Sutton. I'm an associate professor of marine science at Nova Southeastern University. I'm the PI, the Deep End Consortium. My specific field of interest is pelagic ecosystems. I'm more of an empiricist, so the food web modeling I've done are pretty crude relative to what you all do, but mostly our goal is to census the offshore Gulf of Mexico after Deepwater Horizon, then see, come up with a faunal inventory, and then apply some quantitative metrics that other people can use for modeling efforts for synthesis. So yeah, that's me.
Great. And Callan's also on the call. I think that's it.
Yes. Hi, I'm Callan Yanoff. I help facilitate the synthesis and legacy efforts for GoMRI, and I'll be a listener today.
All right, thanks. So the intent here is, as much as possible, to have a conversation rather than me talking at you. Nevertheless, I will talk at you for a couple of minutes here just to share some framing thoughts, and then we'll kind of shift gears to a more interactive mode. I should also welcome the attendees who are listening, and I'll mention that I'll feel free to interrupt me at any time with questions, and if you're just listening, you can put a question in the chat. But when my screen is sharing, I can't see the chat, so if anybody sees a good question there, please just bring it to our attention, because I'll miss it, although I'll try to check in from time to time. Okay, so we're talking about integrating models that answer stakeholder questions across the whole space of sort of the oil spill problematique, which immediately begs the question, who's this for? What kinds of questions are we trying to answer? Who are the decision makers who are going to respond to this information? What other stakeholders might be involved, people who are influenced but maybe don't have a say or a strong connection to the particular decision? Who's going to change their behavior as a result? And then what kinds of questions are we going to answer, on what time horizons, and how much detail do you need to answer those? Then there are also a set of logistic questions around kind of the practicalities of integrating models. Where are you going to get the data? How are you going to chain the models together? Are you going to do that with data flow or APIs or meta models? More about that in a moment. And who's going to run the models, disseminate the results, run the process, keep things up to date, track performance, and so on, which all leads to the question of how do you have a modeling ecosystem that kind of co-evolves together to get all these things done. There are, of course, possible questions on different time horizons. This is kind of one dimension of what's the question. So there's a tactical time horizon. When a spill occurs, what should you do on the ground in the moment to respond? And actually, I understand there's a separate GoMRI task area that looks at the operational questions. And then there are probably a lot more strategic questions around, how do you respond on a longer time scale by adjusting your coastal development trajectory and allocating resources to long-term recovery and strengthening communities and things like that. These sort of roughly map to another dimension too, or they hint at another dimension, which is scientific questions versus policy questions. If you're trying to understand how things really work scientifically, you have maybe a slightly different approach to modeling than if you're trying to answer policy questions, where you're forced a little bit more, I think, to include things in the decision that may be wildly uncertain. So lots of dimensions to the question of what's the question. And basically this is a hard thing to do because you're interacting with people who don't know the system as well as you do, who have mental models that are confounded by the separation that time and space impose on causality, and therefore they may not appreciate a lot of nuances of delays and feedback and nonlinearities and even the simple dynamics of accumulation. And then, of course, since you have such diverse interests involved in a problem, ultimately you want to have lots of different ways of looking at the outcome. So different decision-making situations or different stakeholders can find something that's relevant to the way they want to think about the problem. And kind of surrounding everything is the question of uncertainty. There, sort of the known unknowns and the unknown unknowns and so forth. And a big policy challenge is always that people tend to start off in a mindset of predicting what's going to happen and then figuring out how to respond to that prediction. But of course, that prediction will never come true. So to the extent that we can, it's nice to use the models to embrace the uncertainty and help people to switch to a mindset that's sort of a hedging mentality where they're making decisions subject to the variety of uncertainties that are out there. When you get down to actually building models that help to embody these things, then there are a number of possible approaches. So what you tend to start with, and what certainly exists here, is a portfolio of independent models that all tackle different subsets of the problem. And actually, there's a lot that could be done to leverage the portfolio simply by creating kind of an organized portal in some sense to the results, so that it's easy for people to take a question and translate it into who understands this system or who has a model that answers my question. Then another thing that's happening a lot, it appears, is federation of models. So hooking large-scale models together through either an API or a data flow, or explicitly including one in another, to build an integrated model. So for example, taking the ocean physics and plugging it into the ecosystem. Kind of the extension of that is to build bigger, more and more integrated models that combine all the dynamics of interest in a single model with lots of spatial and temporal and other kinds of detail. At some point, that strategy always breaks down just due to combinatorial explosion, but the frontier of what's possible is also moving as technology and our software and so forth get better. And then finally, there's kind of a different integrated approach, which is to start top down with an extremely simple model that just approximates the components that would otherwise be federated. And that's always kind of unsatisfactory in a variety of ways, because you take complicated dynamics in an ecosystem model that has tens or hundreds of species in it, and you boil it down to 1 or 2 boxes of biomass. And in some sense, you're always throwing away a lot of information. But on the other hand, that opens up the possibility of bringing in connections to a lot of other dynamics in a more manageable way. It's kind of interesting that in the climate integrated assessment space, you see all of these things going on. So, you know, the fifth assessment and the other assessment reports are essentially portfolio approaches. It's a report that integrates a lot of different models at different scales. There are both federated models and mega models, and the mega models need supercomputers and huge budgets. And then there are also a lot of meta models, both on the kind of the physics side and the economy side. And probably the most famous model by name in the whole space is William Nordhaus's DICE model, which is extremely simple. You can literally draw it on a napkin, and yet it has been extended and replicated dozens or possibly even hundreds of times, and it's had a lot of influence on things like the social price of carbon calculation in the United States. Unfortunately, in that case, it's not all good. It's really a double-edged sword, because early versions of the model, I think, anchored carbon prices at low levels and things like that, just because the model had a lot of flaws, like not conserving carbon and not properly capturing temperature dynamics. So all these approaches have pros and cons, and part of what we're trying to do is map out what exists and figure out what the prospects are for these strategies going forward in connecting up all the spaces. And these are the, so this is John Shepard's conceptual diagram. It's the basis for the webinar structure, breaking things up into physics, ecosystems, socioeconomics, and health. And there's a green circle in the middle, which is interventions in all of these things. And of course, it's sometimes hard to place these in one box or another, and a lot of them have knock-on effects through different pathways. So for example, choices about dispersants affect physics, propagate into ecosystems, and therefore affect health. So actually, before I move on, any questions, comments, thoughts along the way? Okay. So on Monday, we heard about vertical connectivity and essentially network effects among species, and about deep end, which, as Tracy said, is more the empirical side of things, essentially inventorying what's out there, and about ecotran, which is a vertically disaggregated ecosystem model. And essentially, these are all in the space of tackling a bunch of questions that came out of the Sea Grant stakeholder contact. So these impact a lot of these things about food web dynamics and propagation of dispersants into the food chain and things like that. Looks to me, so this this network diagram here, which you don't need to digest in any detail, is a subset of a network I built out of all the Sea Grant questions in a list that we picked up with their assistance. So I took a list of stakeholder questions and tagged things according to what the questions were about. So if they mentioned toxicity or wildlife or dispersants or other kinds of things. And this is what you get. And incidentally, this is interactive and online, so you can play with it if you want, but we don't need to get into that at the moment. So the yellow dots here are questions that were assigned to the ecosystem bucket, and the blue dots are things that were assigned to the physics box. And there's a lot of tight coupling here, because there's a whole constellation of questions that are about how does oil and dispersants and other toxic components propagate into the ecosystem, and to some extent also the reverse of how does the ecosystem help to degrade or transport or store the oil. So it appears that there's this tightly coupled question space, and it appears that there's also a tightly coupled set of models that are well on the way to integrating these things. So the connectivity modeling system being one example. So I guess my first question for you all is, to what extent is that a true statement, or is kind of the physics to ecosystem connection already pretty well developed and have a clear roadmap for what needs to happen next?
Tom, this is Cam Ainsworth.
Yeah.
Before we get into this, I just wanted to suggest that, there may be a few attendees who would like to be able to speak. And I know that not all of the panelists probably are going to be, talking too much. So I don't think we're going to have any problems with people talking over each other. I wonder if it'd be possible to invite any of the attendees who would like to talk to send a message in the chat box, and we could add them into the panelists.
That's a great idea. I can upgrade anybody who wants to. I think there's actually a raise your hand button as well, that would let you indicate that. Absent that, I can just run through the list and enable everybody.
Well, maybe we'll wait for, I doubt everyone, I think there's probably a lot of people here who just who would like to listen. So maybe
sure,
indicate by either raising your hand or send a message in the chat box if you'd like to be moved over to the panelists. I don't think that you'll be able to talk if you're in the attendee list. Having said that, I think I'll just take this moment to comment on the question that you asked. I was kind of, I wanted to say more about Atlantis on Monday when we did the ecosystem presentation, because, there's not a lot of linkage with human health directly anyway, but there certainly is a linkage to the physical oceanography, as you can see on the screen. And there was also a linkage to the socioeconomics. So as for the physical oceanography, we've done not only the, coupling with the CMS model from Claire Paris's group, and Natalie Perlin is on the call, and she did a lot of the heavy lifting for that effort. And so we took circulation data from CMS, but it wasn't just the circulation. They had the oil concentrations. And so they incorporated directly into their hydrodynamic model rates of biodegradation based on high pressure experiments. It was very, I'm not a ocean physicist, but I know they had learned a lot about how the gas dissolves and how it gets entrained in the water. And so they really incorporated quite a lot of cutting edge physical science into that model before it even got to Atlantis. And then, of course, the oil concentrations were used, and we applied a dose-response relationship, which varied for different species, so that things that were more closely associated with sediment, for example, got a greater dosage than things that were pelagic. And so we incorporated that into Atlantis, and ultimately we produced, we simulated the circulation data from CMS both for the historical spill as close as we could represent the actual oil spill, but then we also did a paper which is now published in one of the recent Sea Image books that just came out, where we tried hypothetical oil spills, one on the West Florida Shelf, one which was in the same location as the Deepwater Horizon, but during a different time of year. And then there was a third simulation. And so those are the ways that we incorporated the circulation data into Atlantis. And then also in the Sea Image book was a paper that was done in collaboration with David Yoskowitz and his group at Texas A&M, Corpus Christi. And we used outputs, catch data from Atlantis, and they applied what I think can be described as an input-output model to determine shore-based impacts on shore-based industries. So that was a pretty good linkage there to and from Atlantis.
Right. So then, so that's the socioeconomic and the physics link. And there's also a health link through sort of toxic content of seafood consumed and occupational exposure and things like that. Is that underway, or has that been done?
Well, you know, we thought about that early on in the project, and I never ended up doing much with it because my understanding was that the PAHs don't really bioaccumulate. I think they're processed pretty effectively. So the only thing, I mean, I'm sure there's someone on the call who knows more about this than I do, but my understanding is that the only real bioaccumulation threat is in heavy metals that are associated with the crude oil. And I know that the Deep Sea Consortium at FSU had a component looking at heavy metal concentrations. And in fact, they began building an Atlantis model expressly to look at that, but that they, at some point, their postdoc left the project and was derailed a little bit.
Yeah, I'd like to, if I may speak, this is Helena. I'd like to maybe add, I'm not an expert in this, but I've thought about how to link potentially to human health from the ecosystem side. And as far as direct physical health effects, people consume fish and shellfish. I understand that maybe the PAHs may not accumulate in the edible portions, what we consider to be the edible portions of the fillets of the fish. Steve Morawski was very gracious on Tuesday or on Monday and shared a document that provides some accumulation rates in various fish. Maybe that can be integrated. So once the model of the fish quantities and then maybe the actual removals by fisheries is estimated, that then goes to consumption, and maybe there can be some assumptions about how much people consume in terms of fish consumption, and then that can be a link back to human health. But in addition to what we consider fish, there's other kinds of food in terms of like oysters, shellfish, octopus, other kinds of organisms that people may consume that may accumulate the PAHs. In particular, I think of oysters as really effective filters in the water, and they could accumulate particulates and maybe even absorb some of the oil components directly. And I think that may be an interesting connection back to human health.
Interesting. Yeah, I think he mentioned on Monday that as long as you weren't eating the liver, you weren't you weren't getting the bioaccumulated toxins. But so that's not necessarily true for all things.
Yeah, but also some people eat the liver. Some people, well, you put in a soup, or it's, depending on the culture. Some people may eat it, those components. So maybe there's a fraction of the population that may be at greater risk because they consume the head or other parts of the fish that are not normally considered consumable.
Right. So let's see. Well, we'll come back to this question in a couple of minutes, because based on the last two webinars, I made kind of a speculative diagram of some of these dynamics, and I want to talk about that. Let's see. So the major models that I've heard so far are the CMS, Atlantis, and Ecotran. I'm curious what distinguishes Atlantis from Ecotran.
This is Jim. I can answer that.
That'd be great.
Well, Ecotran, it's simpler, much simpler physics, and it does not track functional groups through life stages.
Okay.
That's one of the major differences.
So you have a bucket of grouper biomass, but you don't have larvae and juveniles. And
larvae and juveniles are distinct groups, but there's no recruitment from a juvenile box to an adult box in Ecotran.
Okay. And is the purpose of that simplification essentially to get more speed and maybe more other things out of a complex network?
That's a nice way of putting it. The better way to put it is I haven't done that yet.
There's a lot of that around.
This is Cam. Let me make a quick comment. In addition to CMS, I also did want to give a shout out for Bob Weisberg, who is also, I don't know a lot about it, but I know he did circulation modeling. I think it was for the Deep Sea Consortium, and that would be using WFCOM, which is a variant on HICOM. And so that would be physical modeling, kind of the equivalent of CMS, although CMS has a lot, as I mentioned before, it's not just the ocean physics, it's also oil concentrations and breakdown rates and things. So there is quite a bit more biology in CMS than simply on HICOM. But as I said, I'm not quite sure what Bob was doing.
Could I jump in?
Sure.
With that. This is Natalie Perlin from University of Miami. I work with CMS. Actually, CMS is Lagrangian particle tracking model. So as a physics, as a hydrodynamics model, it uses the HICOM output in order to advance the particle. And it has the oil physics, not the ocean physics. So it relies on HICOM output or whatever, whatever model can provide the physical forcing.
So HICOM is a three-dimensional GCM that gives you a velocity field, and then you use that in CMS.
It's actually not a GCM.
Okay.
It's a regional model, even though now they have a lower resolution global model, but initially it's just a regional atmospheric model.
Yeah, but I think CMS probably uses Gulf HICOM, which
yes.
So the difference there is that these two efforts, the University of Miami effort and Bob Weisberg are kind of serving different purposes. The work by Bob Weisberg, his FECOM model uses HICOM for boundary conditions, but within the West Florida shelf, it uses a much finer grid structure to account for like eddies and conversion, things like that. So it's.
Did I get the acronym right there? Or
I think it's FVCOM.
Well,
FV,
no?
yeah.
Actually,
Standing for finite volume, or
actually, to tell you the truth, I misspoke. He calls it WFCOM for
okay.
West Florida, but you're right. You're right. It is the FECOM, or it's the same code with a different.
Right.
And one other thing I wanted to mention is I see Paul Montagna is on the call. He and Melissa Rohal worked on a EcoPath with Ecosim model, which is, I think Jim also has one. But theirs was just the West Florida shelf, I believe.
Yeah, that's actually Kelly Robinson has one for the north central shelf as well.
Yeah. Okay. And as I recall from your presentation on Monday, EcoPath is still a level simpler than EcoTran.
That's yeah.
Or is it's sort of different rather than simpler?
It's different. The EcoTran allows the ability for a coupling with mechanistic physical models.
Mm-hmm.
Is that a add-on to EWE, Jim? I mean, is it integrated?
No. Essentially, EcoTran takes the consumption matrix that EcoPath would generate and works with that as the model structure. So it doesn't integrate with EcoPath at all.
Okay. Tom, you could mention, in addition to Kelly's, there's also Melissa Rohal. She has a model that she used in her dissertation.
Is it Rohal or Woe?
Rohal.
Got it. And I think you mentioned an output model for fishing economic impacts.
Yeah, well, gosh.
Was that Remy or something?
Well, it was David Yoskowitz, but I can look up and tell you who the lead author of that paper was.
Okay, yeah, we can look that up offline. That's okay. And I would imagine there must be a lot of other sort of smaller models that are looking at even more narrow or granular sorts of questions. But it sounds like these are the kind of the big players that are in the integration space.
Yeah, the lead author was Krista Kort. Christa. And Court, Court.
All right, I'll look those up after.
Also, Krista will be a speaker in the webinar next week.
On socioeconomic. Oh, okay, great.
So you know.
Yeah, that'll probably cover that then. Okay, I'm curious about a little more about what's in the ecosystems box. So kind of thinking about that at the moment. We heard a lot on Monday, and we've talked a lot about fish and things like that. But what about other things like coastal marshes and seabirds and shellfish and the ecosystem valuation of services provided by, say, wetlands and marshes for coastal protection and things like that. To what extent are these things in the models?
Well, I'm sorry, go ahead, Jim.
Oh, I'm sorry. I was the higher trophic groups. They are in the Atlantis and Ecopath and Ecotran models. I don't know if there's any linkage to their value to quantify their value as in terms of coastal protection at all, though.
And when you say higher trophic groups, things like
non-commercial things.
And
yeah.
I guess porpoises and things like that.
Yeah, I was using that as a catch-all for things that aren't of direct commercial value.
Right.
There is a dynamic link in Atlantis. We have biogenic habitat forming groups. We've got seagrass. Well, probably the only one. Mangroves. No, I don't think we have mangroves. But we have seagrass, and then we've also got some. That's linked dynamically, so that when seagrass grows, there's more seagrass habitat, and then we've got species that depend on that habitat. So if a seagrass were to grow, then those species would do better. It wasn't really an emphasis of the modeling, and the problem is that we never ended up putting in any functions to. I mean, that was kind of I don't know, maybe an oversight, but we never killed off any habitat.
So in other words, the oil doesn't kill the seagrass?
Not explicitly. I mean, we apply oil functions to fish, and so you can think of it as, a fraction of that would be juveniles being killed in wetlands, for example, but it's not explicitly modeled. So in terms of if we were to ask what is the value of a 1 acre of restoration of wetlands to the commercial fisheries, that's a question we could answer, but we haven't put the linkages in yet to do that.
Okay, and actually, if you look at the stakeholder questions, there were a lot of things kind of about ecosystem services in degradation of oil in there as well. So can you say something about that based on, the sort of, if you have a healthy ecosystem, is the half-life of oil in the water column shorter?
Well, certainly there's nothing that I'm aware of that would tell you how the system would degrade the oil, with the exception of the high-pressure biodegradation experiments from Sea Image. But that's at the microbial level. But there's certainly a lot to do with ecosystem services. It's just not explicitly linked to habitats. Like Melissa Roja, for example, her whole project was on ecosystem services, and Atlantis. That's kind of what it does in terms of fisheries catch and biodiversity and other things.
Okay. And then does the loop get closed the other way so that the seagrass regeneration or habitat expansion is influenced by the amount of nutrients they're getting from other levels?
Yeah, that actually is in there. And light is also in there, but they're not. If turbidity of the ocean increases, the light attenuation increases and the benthos gets less light and the seagrass does. So that those linkages are in there, but we never put in, I mean, we had our hands full just putting in the mortality functions for fish and the impact on recruitment rates and stuff like that. So we never really concentrated the manpower that we needed to represent how seagrass or mangroves are affected. So that's an area that needs more work.
Right. And then you mentioned microbes. How low do these models go in terms of?
Yeah, well, the Atlantis is kind of spread, kind of touches both worlds, the NPZ models and the upper trophical and the fisheries models. But it's definitely still a fisheries model. It's typical to outsource the lower trophic level dynamics to a more capable NPZD model, but we never did that for this project. And I don't know, does anyone else on the call have a better idea of where that model has been done? Lower trophic level model?
I don't know if Jim has run into that.
Oh, not for the Gulf. Ecotran is similar. It can be driven by an NPZD model or have just Michaelis-Menten uptake kinetics for phytoplankton built in. And bacteria can be defined as separate functional groups, or often, depending on the project, we just have bacteria included. The process included implicitly as a breakdown rates of detritus.
Mm-hmm.
You know, back in about 2014, 2015, John Walsh and his research associate, his name escapes me, but John Walsh and his group did NPZD modeling using a model called ZooSim, and that was for sea image. And that was a lower trophic level model. We always meant to work together, but John retired in 2015, and we were still probably several years away from being able to dynamically link our models together, so that never happened. But ever since he left the project, I'm really not aware of anyone who looked at, like, you know, planktonic impacts or anything like that. But he had, I mean, it was an aggregate box model, and he had something like 8 functional groups. C image is C as in Charlie.
Oh, C, yeah. Okay.
It's one of those. Yeah, perfect.
Okay. Well, we may come back to some of these things again as well. Oh, I did have one more question. So when you federate an ecosystem model like Atlantis with an NPZ model, how does that work kind of mechanically? Do you sort of transfer the equations of one into the other, or do you link them?
Well, the models like Atlantis and EWE operate at 2 course of time steps to effectively predict the planktonic dynamics. So we sometimes link to these NPZD models. The way it goes is that the fisheries model like Atlantis will provide predation mortality on zooplankton or grazing rates on phytoplankton. And in return, the MPZB model provides plankton and zooplankton densities or biomass, which acts as food for the fish. And generally, the MPZB model, which will typically operates like at 6-minute or 12-minute time steps, compared to, Atlantis is 12 hours, and that's really fast for a fisheries model. Ecopath is 30 days, and Osmos is similarly a long time. So generally what happens is that the MPZB model cranks away for hours and hours and hours, processing a 12-hour period, and then Atlantis does a revolution, and then it goes back to the MPZ model. So it's a very uneven use of computer resources.
Right, yeah. We have the same problem in the electric power sector, where capital's turning over in decades, and then you have an auction every 30 minutes to decide who's generating. Okay, interesting. On the data side, DeepEnd is monitoring the fish. Is there anything that's monitoring kind of the microbiome or the seagrass or other resources in a systematic way?
Hey, this is Tracy. I'll just jump in real quick and say the microbiome work is mostly done, I believe, by EcoGig and Mandy Joy's group. So that would be a tie-in with one of the other core themes. And DeepEnd does have a microbial component for the offshore. So we've been doing metagenomic sequencing of the biomes from the surface down to 1,500, and they do have at least relative quantitative data.
Okay, cool. That's helpful. So let's just keep moving and talk about more connections and structure and so forth. Let's see, this is a slide that I picked out of a ecosystem valuation article from Resources for the Future, which we used to jokingly call Resources for the Immediate Future. I don't vouch for this, but I'm curious. So this is looking at economic damages from oil spills. I'm curious if there are other ecosystem connections here. So they've got fish and invertebrates on agriculture, aquaculture. Is aquaculture much of a sort of an economic sector relative to free ocean commercial fishing in the Gulf?
Well, I would say that, this is Missy, I would say that aquaculture, particularly of oysters, is growing significantly in the state of Alabama and now moving into Mississippi, but also in Florida. And it's definitely something that a number of the fisher folk have begun moving to, or some different firms have begun moving to, as the native oyster populations have undergone degradation, not just from the oil spill, but from all of the increasing flooding that we've been having, freshwater inputs, et cetera. So I would say it's definitely a growing sector in the Gulf.
Uh-huh.
And there's a huge push right now within NOAA to start promoting offshore aquaculture. So it might not necessarily have been incredibly impacted by Deepwater Horizon, but it's definitely something that's on the radar of a lot of fisher folk, of saying, in the event of another spill, what about my investment in my aquaculture facilities?
Okay. And I guess then sort of a third dimension is recreational fishing, which certainly ties into tourism and things like that as well.
If I could, just one other comment when we were talking about linkages with ecosystems and human health earlier. There's the more direct linkage, the possibility of consumption of something that's toxic, leading to detriments to human health. But there's also the idea of decreased stocks of available fish, meaning that markets then potentially make fish more expensive, which means folks are less likely to be able to buy it, and all the health promotion that's gone into reducing consumption of red meats and fatty meats in favor of having a more seafood-rich diet. If you have decreased stocks and impacts to access to those types of foods, for the nation, not just coastal communities, I could see that being a direct human health impact.
And then, of course, that also affects recreational catch and income in the fishing sector and so forth. That propagates through the economy as well.
Yeah.
There was, closures, fishery closures, which kept changing over the course of about 10 months, which we integrated dynamically into Atlantis. Those are driven by human health concerns.
And that's, is that the work that I think Claire showed us 2 weeks ago in the health webinar?
No, she never. No, that wasn't us. I never really presented that. It was
okay.
Done by one of my grad students.
So it's a good point, I think, to transition here to a diagram I started building up based on the last couple of webinars and other material that I think starts to capture some of these dynamics. So if we could talk through this a bit and throw rocks at it, that would be great. So the 4 boxes are the 4-box framework from the that organizes the webinars, and I've taken out the decision bubble in the middle and made some of the links around fisheries more explicit here. So let me just kind of talk through this and interrupt me whenever I say something stupid. So the physics box is giving you physical transport, particle tracing, and so forth to tell you where the oil is going. And I suppose there must also be photo degradation and things like that in there as well. But we haven't talked about that yet. But the net result of that is transport of chemicals into places where the ecosystem lives. And then within the ecosystem, you have fish. So there's the fish, and then you have other species. So I've sort of aggregated everything into 2 trophic levels here for purposes of kind of cartooning this. And then potentially within are toxins and within the other species. And since they're all eating one another and passing things around, you have bioaccumulation. And I guess the gray area here is the extent to which, say, vertical migration of the ecosystem members is involved in moving the chemicals and nutrients around as well. So that's kind of the physics to ecosystem piece. Is that a reasonable cartoon of what's happening? So then the pathways to health and ecosystems are partly through toxic exposure from consumption of fish. And so we talked a few minutes about whether that was a factor or not. So maybe it's less of a factor for fish unless you're eating the liver, but still a concern if you're eating oysters and other things.
Can I add here?
Yeah,
We
yeah,
need to
please.
have another arrow from other fish biomass to toxic exposure, because not everyone, I mean, there's other organisms besides fish that people consume.
Oh, right. So there's other species harvest. So essentially you could replicate what I've shown here for fish, and I'll just give that a different color. So oysters and other things, and that's all leading to exposure as well, based on the toxic burden that those other species are carrying. Oops. So it's oysters and shrimp and so forth. Okay. And then at least for fisheries, things that are managed, and I guess oyster reefs and things like that must have safety closures and other kinds of management associated as well. So the amount of toxic burden on people is actually, it's a function of how toxic are the fish, but also then how much do you harvest, which is managed by closures and maybe other kinds of sort of limits, which are implemented for two reasons. One is perceived safety based on the toxic load, and the other being assessment of the health of the stocks, setting the closure date for a species in order to preserve the resource. So a spill might have two effects. One is toxicity affects the fish biomass through mortality, so if you have less biomass, then you have less stock, you close the season early, so you have less harvest. That means less exposure. And the other is that based on the perception or the measurement of toxicity, you might close down the harvest early or in a particular region as well. So that's the toxic load effect, which then influences health status directly. But then there are a bunch of indirect paths as well. You're spending money on fishing effort and then hoping to reap a harvest. That determines your income and also your employment in the fishing industry and so forth, which then has a variety of effects on the community. So it affects the kind of the immediate economic viability of the community, which has mental health and mental health impacts. And it also, the income directly affects the affordability of healthcare, to the extent to which individuals are responsible for that. Both of those affect health status. Health status affects productivity and morale and things like that affect income, employment. And then in the long run, you have things like migration of people who are attracted to some extent by job opportunities, whether it be fishing or tourism or simply some other sector that is supported by those things. So the boat maintenance and fueling and all the other things that have to go along with the industries that are economically directly affected by fishing. And then, of course, there are a bunch of other influences, the non-fishing economy, other aspects of recreation and so on. And all of these things also affect coastal development, which affects wetlands and marshes and other aspects of habitat. which in turn influence ecosystems. And these are all, I'd say this link here is somewhat longer term dynamics. Are any of those things in Atlantis and Ecotran and so on as drivers, changes in, say, exogenous changes in coastal habitat?
Not in Ecotran. It can be, you can generate functions, I imagine, that you can apply to Ecotran, but no, it's not built in.
Mm-hmm.
Yeah, Ecopath and Atlantis are both capable of representing that, but again, it wasn't sort of a priority. The oil, direct impacts from the oil was sort of, enough to keep us busy for the. Also, I'd like to suggest that human health, I think, has a pretty strong feedback onto ecosystems and socioeconomics because I mentioned the closures, the fishery closures, which altered the distribution of fishing effort and the amount of fishing effort, and probably even more important was but there's no link from human health to the closures. Even more important was the loss.
Let's see. So what does that link look like? Is it observation of actual health impacts changes the perception of safety, which then, or is it really all this sort of?
Well, there's two mechanisms. There's reduced consumer confidence, which had a major impact on prices that fishermen were getting.
Mm.
And there was also closures mandated by NIMS, the National Marine Fisheries Service, that closed at some points. I don't know, like maybe as much as 20% of the Gulf. It was quite a large area. I might be overestimating that, but they were large closures that lasted a long time. And I don't know if it reduced the total fishing effort, but certainly changed where fishing was happening. But probably the bigger effect was the loss of consumer confidence and the resulting decrease in prices that fishermen were getting.
Right. So.
And those were driven by human health concerns, even though right from the beginning, the seafood safety work that NERDA was doing didn't indicate any substantial health risk.
Yeah, so it really was a question of perceived safety rather than actual safety, and in a sense, in the long run, it obviously matters what the real risk is because people get sick or not. But in the short run,
fisheries closures did their job. I think the reason why the seafood was safe was because those closures were comprehensive.
I see. Yeah. And then the trade-off that's often advanced is that the closure is intrinsically taken by some people as a sign that there's a safety problem, and that may affect tourism and things like that. So the closure is a double-edged sword. By making things safe, you're also confirming the suspicion that there was a problem to begin with, whether there was or was not. Okay.
I had a question for the ecosystems group because I was trying to draw parallels from the physical models because when I think of physical models, I think of nearshore models versus offshore models. I was wondering if there was a parallel in the ecosystems as well, whether or not there's models that focus on the offshore communities versus those that focus on the nearshore that would, you know, be specialized towards looking at the influence of wetlands, for example, on shrimp and other organisms. So I just wanted to get a general sense of the overall, how the modeling framework is for ecosystems.
Well, this is Tracy. I can throw in a quick empiricist view of this, and that is that there's a huge difference offshore versus inshore in our knowledge of rates. So for offshore, we really don't have near as much information on rate processes as we do the coastal domain. So necessarily the models will be quite dissimilar.
The ecosystem models do consider inshore and oceanic regions as distinct submodels as well.
Yeah, but often, you know, if you're talking about, it really depends on what species you're talking about, because, you know, a juvenile, say a fish that is caught commercially, may live as a juvenile in inshore estuaries and as a subadult out on the shelf or the slope. So they're really, you know, to capture different life stages requires that you model those separately, or I mean, you know, together.
Yeah, I wanted to comment on that too. So I was curious when I was seeing the different buckets of models that are being produced, and I wasn't really seeing spaces where there was integration between those inshore offshore places. So I'm glad we're having this discussion about it, because there's a number of not just commercially important species, but, you know, other species, but certainly commercially important species like shrimp or blue crab or other commercially important or recreationally important fishes that heavily utilize inshore habitats as necessary parts of their life cycles. So if they're being modeled as separate buckets, is there a way to show that linkages in the transfer of not just energy, but resources or impacts or things like that between those distinct types of habitats?
Well, the models do consider migration, you know, not trophic movement, but migration between subregions. Is that what you're thinking?
I was thinking a little bit more trophically speaking, since you've got different life stages utilizing different types of habitat in distinct regions differently. You know, that they are interacting with the ecosystem differently at different life stages and in different regions within the Gulf. So I wasn't sure if there is already like a way to integrate those types of models together, if they're already being modeled kind of separately from the juvenile stages to the adult stages.
Yes, I think Atlantis does that, doesn't it? I mean, it has like nursery grounds for young fish.
Yeah.
In shore, and then they as they grow, they migrate and move out to deeper waters.
Yes, it does have explicit ontogenetic migration of, you know, to and from estuaries. And also there's larval dispersal dynamics. Although we haven't spent enough time on that, but you know, it achieves this horizontal connectivity. That was one of the themes of the talks on Monday. Although the inshore-offshore linkage, I'm sure there's more that could be done to look at that.
Okay. Interesting.
And just to add a little bit to when you mentioned don't know the rates on your notes there, I
Yeah.
think the most important rate in a modeling domain is production rate. It's the age and growth of things out there we don't know, so it's hard to provide the P and the P to B ratio.
Uh-huh. So is it just that these offshore species aren't understood all that well?
Yeah,
Is it?
mostly
Yeah.
it's methodological difficulties compared with coastal forms and validating our estimates of production. So, and then for things like invertebrates, we don't even have a method for aging or getting at production of the invertebrates. Usually we're just dealing with the standing stock, so that turnover, that's a mystery everywhere in the world, not just the Gulf of Mexico.
Yeah.
Yeah. Just thought that might be relevant.
Oh, interesting. Okay. And are these species that are of commercial interest or things that
Not
are in
yet.
other levels for the most part? Or
Yeah, I say facetiously not yet, because right now there's a move afoot to start commercially harvesting mesopelagic resources. Don't know if that'll happen in the Gulf or not, but have net will travel these days. And as one fishery gets depleted, usually they'll fish something else.
this is sort of the eat the jellyfish because there are going to be a lot of them.
Yeah. Yeah, exactly. Well, mostly it's actually for aquaculture, since you brought it up. The need for protein for aquaculture is such that the wild demand can't keep up. So they've come up with biochemical ways of using non-edible food sources for food for aquaculture. So that's the main driver. I think this falls under the larger question of many of the services offshore of the Gulf of Mexico and elsewhere, or deep sea services, are intermediate services. So they're not final, they're not final services. So it's not food provisioning per se, but it's the prey of things that are commercially harvested. Swordfish, billfish, tunas, things like that.
Yeah.
It's the prey of those taxa, as well as other managed things like seabirds and mammals. So that intermediate versus final services it's a sticky wicket, and it's probably adding too much to this discussion. The point is just something to keep in mind.
So this is kind of the offshore equivalent of using, say, the grizzlies and other apex predators as the poster children for the health of the greater Yellowstone ecosystem or something.
Right.
Interesting. Yeah. I happen to be in Montana. That's why that's top of mind for me. Rather different ecosystem from what you all are studying.
We also have a real uneven knowledge of diet relationships in the Gulf. About 90% of the diet gut content work has been done on the West Florida shelf and in relatively shallow waters. And, that Steve talked a little bit about it on Monday, how they're trying to look at the diet of these large pelagic predators to determine their reliance on mesopelagic prey. Because, one thing we learned with this Deepwater spill was that, a lot of the oil got entrained in the deep water and presumably impacted mesopelagic prey resources. But what's not known is what ultimately that will mean to fisheries, because we don't have a good understanding of how well those sub-food webs are connected.
Right. Although evidently, well, I guess it's uncertain, but it seems that the deep end abundance estimates indicate that there is some ongoing impact, unless you think 2011 was just a really good year, or 2009? Tracy showed a slide with before after measurements, as I recall.
Yeah, no, it was just after. So it was the 2011 year, which we would consider as a default more like the baseline. We have no other data to indicate that it was an anomalously good year, but just being safe and conservative, basically we're just talking about the trend after, but yeah, as far as we know, there's still a signal out there now.
Right.
Well, you know, that was one of the mysteries. Atlantis predicted big impacts on large pelagics, which I didn't see. I mean, I wasn't aware that, you know, it was actually manifested in the Gulf. And I chalked up the difference to their ability to avoid oiled areas, their high mobility. But they you know, their habitat overlapped with the oil, and so did their prey. And it's always been kind of a mystery to me why there hasn't been a greater impact on them.
So there's actually, so at least for some higher creatures, there's a behavioral response essentially.
Well, potentially, but what I'm wondering is that we're going to see it's going to become more clear over time that there was a larger impact than was sort of well, at least a larger impact than I appreciated initially.
Mm-hmm. Interesting. Okay, I want to pursuing some of the connections to other spaces. Just keep sort of thinking about these arrows. There were a few in the question. So this is back to the Sea Grant question network that I built. So one term that comes up is economic, which was actually, and here's the question that we were just talking about: where are we on the recovery spectrum? Which is sort of was a question about to what extent have we now recovered from the ecosystem impacts of the spill? So most of the economic effects were entangled with impacts on commercial food species, and then that in turn was connected to a whole web of other ecosystem questions, and then that leads to a bunch of economic impact questions about fisheries, tourism, restaurants, and then more generally into community resilience and mental and financial impacts and things like that. That also kind of spill over into the health space. Is there anything else about kind of the commercial or economic value of fish or other species that comes out of Atlantis and Ecotran and other models? Or have we pretty well covered that?
I was curious whether or not there was anything like economically that comes out of the available models that's not related specifically to fish or fisheries, whether or not the habitat components of the ecosystem are considered from an economic standpoint, whether it's people's sense of beauty because they're spending money to come down to the coast, or the overall economic value of having thriving marshes and healthy seagrass beds and things like that, whether or not those other non-fishery type economic components are included in those models at all.
So it's so existence value is would be kind of the economist's way of framing that. Are people do people treasure or derive benefits from the mere existence of these habitats, or do they provide other services? I think we mentioned, well, let's see, so coastal protection would be another example of that. So I would speculate that if you connect an input-output model to Atlantis or something, you're basically going to get the fishing sector and maybe a few other things and their spillovers into the general economy. You're not going to capture kind of the insurance benefit of coastal protection from mangroves and wetlands and things like that, and you're not going to capture the willingness to pay for having a nice healthy ecosystem to look at or play in or things like that. I guess you might also capture recreation. Has anybody done anything on this front?
You mean the value of recreation?
Well, I was, so I guess any one of these things, value of recreation or willingness to pay or existence value assessment for healthy coastal ecosystems and things like that, or kind of the intrinsic attractiveness of having certain species around.
That's kind of an age-old question. It's like, what's the value of the commons?
There's different studies that we can point to that did look at ecosystem services, but I mentioned that Melissa Rohal looked at carbon sequestration. Yeah, which in addition to the normal fisheries impacts and stuff, I thought that was pretty innovative. But no, there's definitely, in my opinion, there's been the socioeconomics has gotten the short stick here in terms of GoMRI support. There's a lot more work that's been done on the physics, the chemistry, and the biology of the system than directly on the impacts to humans.
And of course, there's probably some reason for that, which is that it's hard to assess ecosystem services before you understand the ecosystems. Same as, you can't really do climate assessment until you know what climate sensitivity is, at least within an order of magnitude. So there may be some sense to that, but it does seem like there's an opportunity here to begin building more of these connections.
Yeah. Well, doesn't NOAA have a mandate? Not just to maximize, the value of fisheries over time, but to maintain healthy populations of even non-commercial populations into perpetuity.
Interesting.
Like, seabirds and mammal things that aren't harvested.
I don't want to speak for NOAA, but I don't know that they necessarily have a mandate to protect all species. Certainly there's species that are higher priority, and then there's, habitats of particular sensitivity or concern that it's getting like ratcheted up on the priority levels. And obviously they do monitoring for habitat function and, species at a number of different trophic levels, but I don't work for NOAA, so I can't say, but I've worked with NOAA for a long time, and I don't believe they have a mandate to protect all species.
But of course, even if you don't have a mandate to protect all species, as soon as you understand how an ecosystem works, if you have a mandate to protect some, then you probably have a mandate to protect a lot more as the means to achieving that. Go ahead.
There was also a lot of work done by NERDA, which kind of got underway before the bulk of the GoMRI work got underway, and I can't say for sure, but I think it kind of shaped the funding priorities for GoMRI, because NOAA was doing a lot of, NOAA, I meant NERDA.
What's the acronym there?
NERDA, National Resource Damage Assessment.
Ah.
So yeah, I think you have to kind of look at what NERDA did, what GoMRI did as a whole in order to appreciate why GoMRI made some of the choices that they made. Like, so for example, NERDA was responsible, I mean, again, I'm kind of speaking out of my element here, so someone can correct me if I'm wrong, but I think NERDA was responsible mainly for injury assessment for the civil liability cases, and so they got started on that very early, and probably that is a big part. I mean, I think that might be a part of why we weren't, as scientists working for GoMRI, weren't tasked with more relating this back to human communities. I mean, that's my...
So then you're really interested in, what's the injury from exposure to oil during a beach cleanup, and you're not so concerned about whether the seagrass looks nice, essentially.
Exactly, yeah. There was, I don't know how many lawsuits came out of this, but NERDA was responsible for figuring out what industries were impacted. Of course, it's a lot more than just a lack of catch, like someone like me could tell you, but how much condominium prices went down, and tourism, and all these collateral impacts to shore-based industries.
Yeah, I'll just add a quick addendum to what Cam said. So our group worked on the offshore NERDA as well, and really the kind of the concept that as we were taught as we were doing it is that the NERDA was really a legal instrument, and it was one of the most complex NERDAs, maybe the most complex NERDA they've ever had to deal with, again, because so much of the fauna didn't have a direct commercial value, but the overall goal was to evaluate each of the natural resources that had been taken away from the public. So that doesn't necessarily mean just commercial resources. I mean, any natural resource the public did not have access to or could not enjoy, the NERDA was supposed to evaluate that and come up with some compensatory formula. And again, for a lot of the fauna that were affected, because this was so large, there wasn't really a means in place to do that.
Yeah. Interesting.
But also to add to keep going on that string, you are correct. The larger ecosystem, the larger Gulf large marine ecosystem picture was the footprint in which NERDA and GoMRI have operated. So again, it takes us out of the strictly commercial domain and into the larger, if you affect that, it could affect something somebody actually cares about, kind of a thing. And I do think that's, overall, that's the right way to go.
Then this kind of gets to a set of questions that I'd compiled about who's making what decisions. So there's some oil spill related decisions, like how do you run a spill response? And then there's ones like, well, like what's getting reconsidered now, which is safety regulations and maybe leasing decisions, things like that. But then there are a lot of other decisions that are maybe more remote. So, well, let's see, there's coastal development But then you also have things that are happening pretty far away, like fertilizer use in the Midwest that winds up running down the Mississippi and into the Gulf, that nevertheless have an impact. I'm curious if we could, does the GoMRI research intersect at all with these kind of more remote processes, or is it pretty spill focused?
Did you? What? Could you repeat that? Did you say no?
So well. Let's see. I'm wondering. Partly, I'm curious to populate this table a little bit. So I guess the underlying question is, who's consuming the GoMRI research at present? Where does it enter various kinds of decision-making processes? So, partly you're building a general scientific basis for understanding how things work in the Gulf, but presumably that trickles down to various other processes. So NERDA would be one example. If they're trying to come up with an overall liability number for loss of use of various kinds of resources and injuries to humans and things like that, that obviously relies on a lot of the research base. But presumably others, EPA and NOAA and National Marine Fisheries Service and so on are involved as well as the states and local jurisdictions and people and corporations. Do the people on this call have much interaction with those decision-making processes, or are you kind of one step removed?
Yeah, I think it's better.
I think you've got a lot of scientists on this call.
Yeah.
Uh-huh.
I could suggest maybe the Deepwater Horizon Oil Spill Trustees is a body that, I don't know. I think that they're responsible for putting together the. I suppose they're. I don't even know.
Is that managing the trust money that BP put up?
Yeah, but there's several pools, and I'm not sure if they're. Yeah, it is, but I'd have to read to see whether that's part of their initial. I think that's BP put in some initial money as soon as it happened, and then later, when the liability case was settled, and then they ended up putting in more money. I'm not sure if that trustee council.
Yeah, they put up $20 billion initially, and then they've put up a total of $62 billion in losses on their books, some of which was subsequent liability beyond the $20 billion that they initially allocated.
But I have to think that probably a lot of the end users for the GoMRI products would be people involved in litigation, but I think we need a broader phone call, unless somebody else wants to speak up, but I don't know a lot about that.
Well, I can say from Sea Grant's perspective, since our job as the Oil Spill Science Outreach Team is to convey not just GoMRI funded, but a lot of GoMRI funded research about oil spills out to these different agencies, to policymakers, to local government officials, to fisher folk, to other academics. So that's part of the outreach function that we have, is making sure that that science gets translated and into different hands, and it doesn't just die on a periodical shelf. I don't know that it's something that we do as a team to figure out how our outreach materials are being utilized and whether or not that they are getting into proper hands. But I imagine that GoMRI themselves, and if anybody from GoMRI can speak, I don't want to speak out of turn, might have some way that they are maybe tracking how publications might be getting used by different entities. I just know that we, consolidate a lot of science and then turn around and push it out to different stakeholder groups, including, policymakers and government officials, et cetera.
So I'm just giving myself a note here to figure out how to integrate that. So essentially, Sea Grant is reaching out to a lot of different stakeholders across this spectrum and giving them a menu of research that's come out of GoMRI and other efforts, but not so much with a view to targeting a particular decision-making process as it is facilitating dissemination of the research in general, and it's kind of up to the stakeholder what they're going to do with it. Is that a fair characterization?
That's fair, especially given what our team is doing. We're not necessarily brought in when a decision is being formulated to help them make a decision, but we do make the resources available, and those pieces of information that come out in our outreach products are based on, you've been showing it, the different questions that we've gotten through different input sessions. We're like, okay,
right,
we're getting a lot of questions on this topic, so we're going to develop an outreach product that addresses that topic. And so that's how we kind of go through the process to determine where the biggest questions are, where there's research that's available that can help answer those questions, and then we get that information out.
Ah, cool. So you're sort of closing the loop by aggregating the questions from stakeholder interviews and then developing targeted outreach to serve those apparent needs.
Well, we are in a modeling workshop right here, so I think it's fair to say that, yeah, we closed the loop.
Yeah. Okay.
In terms of the safety regulators, there's local departments of health, there's the State Department of Health, and then we have the CDC at the federal level.
Mm-hmm.
But when it comes to seafood, CDC is more human health, but when it comes to seafood, I've always seen NOAA taking the lead on the seafood safety. But then State Department of Health and local Department of Health on safety.
It's really the FDA that governs seafood safety.
Okay.
Not so much NOAA.
Ah, okay. Is the National Marine Fisheries Service under NOAA?
Yes.
Oh, yeah, okay. And then there are local health agencies as well. Are they the ones, is it state and local, I guess, who get involved in things like closing shellfish beds when there's an algae bloom or something?
I know they close beaches, so they're
Mm-hmm.
the ones who issue beach advisories.
So for things like harmful algal blooms, that's there's also FDA programs in terms of closures related to fisheries. There's the state usually puts out advisories regarding beach closures and things like that, and like local counties can have out individual advisories as well. But so it's kind of a combination of that. There's model ordinances at the federal level that then get adopted by state and county authorities.
So in a sense, there's it's kind of interesting. We're building towards an integrated model ecosystem that spans the whole Gulf and connects all the boxes. And if you really want to manage everything in an integrated fashion, that implicitly requires some kind of organizational structure that maps to the kind of the connectivity that is in the models, so that when somebody dumps something in a river in Illinois, or develops a segment of beach in Louisiana or whatever, that all of those effects are felt and included in the decision. But in a sense, that doesn't really exist in the real world because of the stovepipes between all the agencies and the different regional levels of jurisdiction and things like that.
You also have another column to the left of a framework of international agreements, I think.
Oh, yeah. So we shouldn't forget about Mexico, for example. And is that law of the sea and things like that? So that is enough of the Gulf far enough offshore to be influenced by that?
Well, I think.
Well, I will say, unfortunately, the U.S. is not a signatory nation of the law of the sea.
Oh, that's right.
Yeah. So it seems weird to say that, but it's true.
Yeah.
You probably should also, under the federal, add the EPA, who's responsible for the civil and criminal decision making after spills.
Who gets to
You could put
decide
them
on?
under.
Go ahead.
I was going to say you could put EPA under the safety regs as well, because they govern a lot of water quality or quality issues.
Mm-hmm. That brings up a couple of interesting things. So one question, I think I have a picture of this here. These were just some things I picked out in the maps. One thing that was pretty, I guess I don't have the detailed map of it. Yeah, oh yeah, I do. That was on a lot of people's minds in the Sea Grant questions was, where'd it go? Sorry, was use of dispersants. I remember that getting a lot of attention in the press at the time, but it was really a central question, both in terms of its effects on the physics and on the food chain and on the kind of the immediate health of responders and so forth. Are there some particular dynamics that lend themselves to understanding the kind of the constellation of questions around this that are in the ecosystem models?
Do we even know what the dispersants were? I remember when the oil spill happened, people were talking about it and were claiming, it's proprietary information and we can't tell you what it is.
Right. I remember that as well. I mean, I think there's some general understanding that it's surfactants and solvents, but apart from that, I'm not sure.
So that's the proprietary one. Oh, sorry, just the proprietary one they were talking about is that right after the spill, BP had its own types of dispersants that they were using. They were basically saying they were proprietary, but once the EPA is the one that actually permitted the use of dispersants then for the underwater injection portion of it. And those ones are known. So those were Corexit 9500A and 9527A. So I imagine, I don't have an MSDS for those particular chemicals, but I imagine those are things that we could find online.
Yeah, so those do have a known recipe essentially.
Yes.
So then that hasn't been explicitly modeled, at least on the ecosystem side? Maybe that's a question for the physics side.
You know, we discussed that, and it's something I wanted to do early on, but we never really got to it. But, you know, there's a question with these dispersants that they obviously, I mean, I think it's pretty well understood that they increase the toxicity of the oil because they're designed to make the oil more water soluble, and so it increases the biouptake rate. But it's an open question as to whether it's worth that short-term problem because it reduces the overall density of oil and you know, hastens the degradation of it. But it's not a you know. So I discussed that with Claire, and she had versions of the model of her model with and without dispersants. So we would be able to look at the relative concentration and location of oil, but we never got to it. So they have that from a physics perspective, but we've never done sort of the cost-benefit analysis of using dispersants, which is, I think, would be a very useful study.
Hi, this is Natalie. So let me jump in because I specifically work with the cases with and without dispersant. So with CMS, what we found that dispersants allow less oil to surface, but keep bulk of the oil submerged. So we end up with more oil staying within the water column. That was basically the bottom line of the result that we saw in the CMS model.
Interesting. So then presumably if it stays in the water column, you're reducing the load on beaches and sort of the aerosolization and evaporation, sort of the air quality effects. Have you modeled that then one step further to what that means for uptake by the ecosystem?
No, right now we were looking at where the oil will end up, whether it will end up more on the surface being dispersed or being in the water column. So as a short-term effect, we do see less oil on the surface, but it has to go somewhere.
Right.
From mass conservation perspective.
So if you guys aren't aware also though that the National Academies of Science just released a massive consensus report on the use of dispersants in oil spill response that came out in April. It's like a 377-page tome that you can download online that talks about a number of different things: state and transport, aquatic toxicology, human health considerations, you know, how it's used in decision making, you know, for a spill response. And so there was a lot of work that went into creating this huge consensus report.
Okay, great. Well, let's see. We're running low on time. I think we've covered a lot of ground. I have a lot of work to do to kind of integrate some of these comments, but I really appreciate the wide-ranging discussion. There's one more topic I'd like to talk about just briefly, which is this one. So we've identified a bunch of questions that haven't been answered yet, or connections that haven't been made. Is there anything that needs to happen to the modeling community in order to support this evolution on and eventually get to all these questions?
Here is Natalie Perlin. What I wanted to mention about the models, given the vast number of oil spill models, I would see it's very beneficial to have some kind of an effort to try to use Deepwater Horizon as a case study it do some kind of a model intercomparison, similarly to as it was done with climates, and to see how well models predict concentrations or some kind of a commonly chosen quantity, because sometimes models focus on what they do best, whether they predict number of droplets or something else, but we want to see how they compare. And then after this is done, the models can be used to produce some kind of probabilistic forecasts, or hindcast, I would say, to see how number of models could be used, given the Deepwater Horizon example, and given the data that was known then, how we could produce some kind of a stochastic forecast or probabilistic forecast. And then each model can get some kind of a weight, how, depending on how good or how bad it behaves, or what the model scale is, or what kind of a particular area, whether it's nearshore modeling or surface modeling. And so we can, in the event of future spill, we can use this approach to do some kind of aggregate modeling or aggregate forecasting. That's my view.
So I think that's a great pitch for something that I think has been very productive in the climate world. So I've interacted,
Yes.
So I've used the CMIP, the Climate Model Intercomparison Project results. I haven't been involved in that, but essentially it consists of two pieces, I think. One is a sort of a meeting by which climate modelers get together and learn from one another about features of the model. And then the other is an infrastructure for generating scenarios, running them, archiving the data, and storing it. And that is incredibly useful, because you then have this gigantic database of model runs that you can use for all sorts of purposes that the modelers didn't imagine at the time, and you can interpolate between them and do things like you suggest, of weighting them by some kind of skill metric to generate probabilistic forecasts and so on. So that's super valuable. The other one I've been involved in a little bit is the Energy Modeling Forum, which is a little looser. So and I think mainly because the problem space doesn't have some kind of really obvious central scenarios to replicate. So in climate, you can kind of do the canonical double CO2 and see what happens experiment. And that's harder in the energy system just because the models are more diverse. But there, they get a bunch of modelers together to discuss some set of scenarios of interest. So each annual iteration will pick, what if there's an oil interruption in the Gulf, or what if there's a carbon tax or whatever, and generate scenarios around that. And then the modelers learn from one another and report out a portfolio of results that at least kind of span the space of interesting possibilities that people could imagine up front. So if that kind of thing doesn't exist now, it would probably be incredibly valuable to create it. Anything else?
No.
All right. Well, we're at the end of our time. I'm happy to stick around and talk with anybody who has further thoughts. But I'd like to thank all the discussants and everybody who listened through the process. I should add that there will be a B session following up on this. So we're going to go through an A session with each of the 4 boxes, and then we'll have more of an integrated picture and some speculative findings, and then we'll have a second chance to go through and talk about how all this kind of comes together as we see it, get some feedback on that, and continue this conversation. So thank you, everyone.
Thank you.
Thank
Thank
you.
you.
Yeah, thank you. Thank you very much.
Thank you.